Okay, today's lesson is chapter 7.3, adding and subtracting with unlike denominators. Yesterday, we learned how to add and subtract with like denominators, but today the key word is unlike, not the same. Okay, so how would you add fractions and subtract fractions when the denominator is not the same? So we're going to explore that today for our objective, and here we go. You have learned how fraction tiles can be used to add and subtract fractions that have like denominators. In this lesson, you will use what you've learned to add and subtract fractions that have unlike denominators. So here's the question. How can you use fraction tiles to add and subtract fractions with unlike denominators? So we have a recipe for trail mix, if you guys see the picture there. Okay, very nutritious snack. So the recipe calls for 1/8 cup of almonds. Okay. Then we have 1/4 cup of peanuts. How many cups of nuts does the trail mix contain? So what is the key word here, Gia? Help her out. Ashika?
The key word is
In the question, how many cups of nuts does the trail mix contain?
how many
Very good. And what does that tell you you need to do?
I need to add.
Correct. So we need to add 1/8 plus 1/4. But look, the denominators are not the same. They're not like yesterday where we just put the same denominator and then we just add the numerators. It's very different. So if you look at our fraction tiles, and you can go ahead and get those out. Okay, so you always want to think of fractions and in its comparison to the whole, to one fraction bar, right? So I need to add 1/8 and 1/4. So when you take the fraction 1/8 and then you take the 1/4 and you put it together, you see that it makes some amount, right? But can I take the 1/4 and change it into a 1/8?
Yes.
Yes.
Can you take the 1/4 and change it into a 1/8?
Yes.
No, it is way too big. The 1/4 is much bigger than the 1/8. You can't take a bigger fraction and make it into something that it's not. Can you take the 1/8 and could that possibly fit into the 1/4?
Yes.
Yes, okay? This can fit into the 1/4. And so what you're going to be doing is how many 1/8s will give me 1/4? So if you take your fraction tiles and you line them up, you should see that if I took 2 of them, you would have the same as 1/4. It took 2 of them and they lined up perfectly with the 1/4. So I'm changing my 1/4 into 8ths. So instead of calling it 1/4, I now call it 2/8. I am. And so then you take 1/8 plus 2/8. Now I can do this because they both have the same what? Denominator. The denominator is the same. Now I can add the numerators together, which will give me a total of 3/8.
Gina had 2/3 liter of water in her water bottle when she started her bicycle ride. At the end of her ride, she had 1/4 liter left. How much water did she drink during her bicycle ride?
Okay, so what is the key phrase here in the question? How much water did she drink during her bicycle ride? How much? Very good. And when I hear the word how much, what am I doing?
Add.
adding. How much equals addition? Okay? So I'm going to take 2/3 plus 1/4. But can I do that? When the denominators are different, can I do that?
No.
No, I cannot. So I need to find out, okay, what that would equal. So again, we have here 1 whole, okay? Then you're going to take your fraction tile and you're going to look at 2/3, okay? So get out 2 of those, the green ones. So 1/3 and then 1/3. Okay? And then we also had, she had 1/4 left. So get that out. Okay? Now, we want to find fraction tiles that have the same units that can fill in this mystery space right here. Okay? So this space right here, I want to fill this in. But we need to figure out what fraction tiles will fill that space in to make the difference. Okay? And if you guys look at your fraction tiles, which one would fit in there? Would 8s fit?
No.
Nope, 8s doesn't work. Does 1/10 fit?
No.
No. Does 1/12 fit?
No.
Yes.
Yes, it does. 1/12 works. So how many 1/12s do I need to fill in there? How many 1/12s do I need to fill into that spot? Fill it in. All right, so if you look, we found out that in order to fill the remaining space after you filled it with the 1/4, you were able to fit 5/12 in there. Okay? So if you filled in 5/12, then you would see that she drank 5/12 liter of water. Okay? You have 2/3 here. She has 1/4 left. We need to figure out how much she actually drank, and that was 5/12. So the answer is 5/12 liter of water. So am I adding here? Is it 2/3 plus 1/4?
No.
Was that correct?
No.
What should I have done? 2/3 minus. So not adding, but you were supposed to subtract. You're taking what she had, taking away the 1/4 that is still left in the bottle, and you only want to figure out how much is in that bottle, that is no longer in that bottle that she drank. Okay? All right, one more. Okay? So let's look at the first example. We have here 3/10 plus 3/5. So go ahead and get out the tenths and the 3/5. So find 3/10, the purple ones. 1/10, 2/10, 3/10, and then find the 5ths. Okay, so you're going to add on 3/5. Okay,
So if you're using
the
fraction
5ths
tiles, you have to show your
are the green ones.
you have to show your
So 1/5, 1/5, 1/5. Okay? comparing that to the whole, okay? How much do you have? So which one is bigger, the 1/10 or the 1/5? 1/5. That means you could replace the 1/5 with what?
2 1/10.
2 1/10, right? So you can actually fit 2 1/10 into 1 1/5. So if I replaced all of those with 1/10 and I added up all the 1/10, how many 1/10 do I have there replacing the 3/5? 6. So now the problem becomes 3/10 plus 6/10, which equals, very good, and 9/10 would be my answer.